50, 40, 30, 20, 10.
Hi, my name is Magnar Nordal. I'm an airline captain and instructor. A few days ago, I posted a video about the instrument panel of ATR aircraft with a glass cockpit. Understanding how the instruments are working is one thing. Using them is another story. Therefore, I will show a video of an arrival and approach where you can see the action on the PFD and the MFD. This is a night flight and the video is a bit grainy, but I hope you find it useful. The flight is from Sukhothai to Bangkok Suvarnabhumi in Thailand. This airport has two parallel runways, and runway 19 right is normally used for landing, while runway 19 left is used for departures. When we fly to this airport, we always brief the approaches for both runways, because we will park on the east apron and ATC will let us land on runway 19 left and the traffic permits. This time we already have received information that we may expect an ILS approach to runway 19 left. We have been cleared to fly north at 3 Charlie arrival. The arrival route ends at a waypoint named Waltz. From there we will receive radar vectors for the ILS approach. I have added the flight guidance control panel on top of this video. The first officer is pilot flying and the coupling is on the right side. The autopilot is on and we use LNAV and altitude hold modes. All nav aids are set and the approach is fully briefed. When the video starts to run, we are 10.6 nautical miles from Norta at flight level 190 or 19,000 feet. We are cleared to descend to flight level 170, which is already set. The video will run continuously without interruption until we touch down exactly 19 minutes from now. To start descent, pilot flying selects VS mode and set the rate to 500 feet per minute with the pitch wheel. The aircraft starts to descend and alt cell mode is on automatically. We must pass Norta at or below flight level 180. And now we do the descent checklist. Pilot flying selects minus speed target mode and set 240 knots, which is normal speed for descent. When we fly into Bangkok, we don't follow the vertical profile given by the FMS, but directions given by ATC. However, we must respect all altitude restrictions. The time of the day is 11:31 UTC, which is 18:31 local time in Thailand. I take a glance at the cabin page. Everything is in the green. The cabin temperature shows 21 degrees and the cabin altitude is 3,800 feet. And the cabin is descending with 100 feet per minute. We are now cleared flight level 140, which is set with the altitude select mode. COM 1 is set to Bangkok approach 121.7. Now I set the next frequency 121.1 in the standby window. Pilot flying adjusts the descent rate to 700 feet per minute. COM 2 is set to 121.5, the emergency frequency, which we are monitoring. In the standby window, we have the company frequency, which we use to exchange information like the arrival time and where to park the aircraft. I'm taking a look at the performance page and the system pages. Everything is good. Pilot flying selects heading mode. I cannot recall exactly why, but he might be double checking that the course is set correctly for the ILS approach. And now pilot flying has engaged LNAV again. The weather radar shows some echoes, mostly rain showers, but there might be a few ground echoes. We will get a better picture when we get closer. This blue arrow shows where we will level off at the selected altitude with the current vertical speed. To determine our descent gradient, we use the 3-to-1 rule. Our track distance to the runway should be 3 times the altitude in thousands of feet. For example, when we are at 17,000 feet, we multiply 3 with 17 and get 51. That should be the distance to the runway threshold. The DME is located 2 nautical miles beyond the runway threshold, so 53 DME is 51 nautical miles from the runway. We are now handed over to arrival frequency on 121.1. We must pass Bravo Sierra 512 at or above flight level 160. We can now increase the rate of descent. And now we're cleared to 11,000 feet. I set the range on the navigation display to 40 nautical miles, so I see more details. We have passed Bravo Sierra 512 waypoint and we anticipate a shortcut. So pilot flying has increased VS to minus 1500 feet per minute. As we are descending faster, the airspeed is increasing and the power is reduced to maintain 240 knots. This gives us a margin of 10 knots to VMO. We are about to reach 11,000 feet before we reach Bravo Sierra 508, where the limitation is 11,000 feet or above. Therefore, vertical speed is reduced to minus 1,000 feet per minute. Another rule of thumb is that on a 3-degree gradient, our rate of descent is 5 times the ground speed. At 300 knots ground speed, we will need 1500 feet per minute. Nav 1 is set to the VOR at the airport. Nav 2, which is on the pilot flying side, is set to the ILS for runway 1 on the left. The standby frequencies are not shown here, but for Nav 1 it's the ILS frequency for runway 1 on the left, and for Nav 2 it's the ILS for runway 1 on the right, so it's easy to switch. We are now clear direct to Lemos, which is a waypoint at the extension of the approach track. It's not in our flight plan. Pilot flying selects heading mode and steers in a general direction towards the waypoint, while I assist him by programming the FMS. This retrim roll message is typical when you make a heading reversal, and we can disregard it. Pilot flying increases the descent rate to 1500 feet per minute as we are more or less on the profile. We clear 9,000 feet. Okay, the FMS is now programmed and we are on the track. Now can be engaged again. We are slightly above the vertical profile. We are passing transition level, which is flight level 130. We set QNH. The weather radar shows a couple of cells. We are well clear of them. I'm setting the tower frequency in the standby window, 108.2. We are on the vertical profile and we could have used VNAV mode, but we are fine with VS mode. Besides, we will have to change back to VS mode soon. As we get closer to the airport, we see more traffic on the TCAS. Our destination, Suvarnabhumi Airport, is here, and Bangkok Suvarnabhumi Airport is here. Because of COVID-19 travel restrictions, there are very few flights around us. We are cleared to descend to 7,000 feet. When we are passing 10,000 feet, we check the cabin. Differential pressure should be close to 4 and cabin altitude should be close to 1400 feet. We are now clear to descend to 2,000 feet and cleared ILS approach runway 19 left. Until further, we continue with L now. The weather radar shows some ground echoes beyond the airport. You can see that those echoes are flat stripes as compared to more circular echoes from the rain showers. Pilot flying centers the heading bug and selects heading mode. Then, pilot flying will change the navigation source to ILS and armed approach mode. We get lock blue and GS blue. I maintain the FMS on my side. When alt cell and GS are armed together, then alt cell will ensure that we are not descending below 2,000 feet before we capture the glide slope. And when we capture the glide slope, then alt cell disappears. The speed is still 240 knots. Air traffic control asked us to keep the speed up, and we are happy to comply. The localizer is now alive on pilot flying side and I change to the VOR on my side. Lock star and glide star, we are intercepting the ILS. The heading bug is set to inbound heading. I change the frequency from VOR to ILS on my side. And now I get the deviation bars for the localizer and the glide slope. GS green, the glide slope is captured. Lock green, the localizer is captured. We are now established on the ILS. Altitude select is set to 3,000 feet, which is the altitude for missed approach. Cat 2 means that both ILS receivers are tracking ILS signals. Pilot flying selects auto speed and the FMS sets the speed target to 170 knots. I set the range for the navigation display to 20 miles. Normally I don't use shorter range because I like to know what's ahead of me in case of a missed approach. When passing 5,000 feet, we call to the cabin crew and tell them to be seated. In other companies, this happens much later. The Cat 2 information means that both ILS receivers are receiving signals. However, this doesn't automatically mean that we are allowed to fly an ILS Cat 2 approach. To do that, we need extra simulated training. Besides, Cat 2 approaches are not needed in Thailand except for very few cases. We keep the speed up as the preceding traffic is well ahead. And now we are handed over to the tower on frequency 118.2. When passing 1000 feet above the selected altitude, we get this alert. The runway elevation is 5 feet and minima is 205 feet, which we have to run up to 210 on the indicator. And from 500 feet and down, we will have many automatic calls, as you soon will hear. When checking the wind, we can see it's almost calm, but the tower reports some headwind. Passing 3000 feet, pilot flying starts to slow down further. The target is 170 knots at 2000 feet. This arrow shows the speed you will have 10 seconds from now if the acceleration remains the same. The altitude alert sums again when we are passing 250 feet below the selected altitude. We are still established on the glide slope and we can disregard the alert. The radio altimeter comes alive at 2500 feet above the ground. When we approach 2000 feet, it's time to configure the aircraft. Maximum speed for flap 15 is 185 knots, but the speed limit to extend the landing gear is 170, so we aim for 170 knots because the landing gear will follow shortly after we have set flap 15. When the flaps is set to 15, the target speed becomes 140 knots and the barber pole set the speed limit to 185 knots. Gear comes down. Flaps 30. Maximum speed is reduced to 150 knots. When the flaps is in position, the target speed sets to the approach speed, which in this case is 99 knots. We do the before landing checklist. And look, now we have 10 knots headwind. When we descend below 1200 feet on the radio altimeter, the autopilot will follow the average signals from both ILS receivers. This is indicated with this dual label. We must be stabilized at 1000 feet above the runway. That means we are on correct path, fully configured for landing, power is set, and before landing checklist is completed. The airspeed must not be more than 10 to 20 knots above the approach speed, depending on company policy. In my company, the limitation is maximum 50 knots. Soon the pilot will disengage the autopilot. This is done by pressing the disconnect push button on the steering wheel. You can also press the autopilot push button on the panel. When the autopilot disconnects, there is a load alert, which is silenced by pressing the disconnect push button on the steering wheel once more. Autopilot off and yaw damper off. The flashing label is extinguished by pressing the autopilot off push button. Those two lines represent MDA.
500,
And here is the ground.
approaching minimums. Minimum.
We have visual references and we are stabilized. We can continue to land.
200. $100. 50, 40, 30, 20.
Pilot flying starts to flare and reduce power. And touchdown. Run idle. $70 knots. The captain has control. That's all for this time. I hope you liked it. Please support my channel by pressing like, subscribe and share with your friends. You can also follow me on Facebook and give a donation with PayPal. Thank you for watching, have a wonderful day and happy landing!